Hello everybody, this is Miss Richardson, and in this video we're going to be exploring how to find the equation of a perpendicular line that passes through some point. So for this problem we do need to know a few background knowledge. We do need to know a few things before we dive in. For example, we need to know what it means for lines to be perpendicular. We need to know the equations of our line. We also need to know how to find the slope of a line. So let's dive in. I took it upon myself to just draw a little diagram kind of depicting what we have going on here. Nothing too specific. I drew the equation of our line here in red down below, and our point is in green down below. And we want to find the equation of the line that would be perpendicular to this red line, but also passes through this green point here. We can imagine that's a line that's probably going to look something like this, something like that. I'm trying to find the equation of that line. And so one thing I need to know is, well, what are the characteristics that we need to know when we're dealing with a line? We need to know maybe its slope, maybe I need a point, or maybe a y-intercept to be more specific, and so on. When I think about the equation of a line, two forms immediately pop in my head, even though there's technically more than two. There's two that are usually my go-to. My first one that I always think about is one that I'm sure we've all heard about before. We have our slope-intercept form. I love slope-intercept form, and I love even more about it how it's named after exactly what it needs. So for slope-intercept form, I need a slope and I need an intercept. Slope-intercept form looks like y equals mx plus b, where m is the slope and y is the intercept. For this problem here, I do have enough information to find the slope, and I do have a point, but I don't have an intercept, and so this form may not be so helpful. Let's consider another form that we can write the equation of a line in. I'm thinking of point-slope form. So similarly to slope-intercept form, point-slope form also tells us exactly what we need to use it. It needs a point and it needs a slope. So point-slope form is written as y minus y1, where y1 is some y value from some coordinate point that we'll talk about, equals m, where m is the slope, times x minus x1. So if I'm trying to use point-slope form, well, I need my slope, which is m, like we said. Let me write that a little cleaner. You said that m is our slope, which we don't know, but we may have the means to find it. And then we said that we have a point, x1, comma y1. So that makes up our point, x1, comma y1. And so as long as I have these two pieces of information, I have everything I need to write the equation of a line in point-slope form. But that's not all we need, because like we noticed, we have a point, but what about that slope? We may need the slope formula. We may need maybe one of these formats to be able to identify the slope. And I'm noticing that the equation of the line that they gave us is in the form of slope-intercept form. Given that it's in slope-intercept form, I can easily just find its slope. Its slope, m, is just whatever the coefficient of the variable x is. I see that this equation says y equals x minus 1, so I'm wondering, what is the coefficient of x here? Well, remember, what's a coefficient? A coefficient is just telling me how many of each variable I have. Like, for example, if I have 10 x's, if I have 10x, that means I have 10 x's, and so on. Here, I only have one x, and so the coefficient of this x term must be 1. So I immediately know, given the equation of this line, which is not the line that I want, it's just the line they gave to me, I know that the slope of this line is equal to 1. Slope equals 1. That's the slope of this line. But what about the slope of my line? I need to know, what does a line being perpendicular do to the slope of another line? And so if I know that my line is perpendicular to this line, and I know that perpendicular lines have opposite reciprocal slopes, well, that gives me a way to find the slope of my line. These two lines are perpendicular, so they have opposite slopes, which means if one's positive, the other's negative. If one's negative, the other's positive. That's what we mean when we say opposite. And reciprocal, what do we mean when we say reciprocal? Well, we're talking about fractions. Some of you may have heard of before. Reciprocals, a little pun that some people use instead of, just to help us remember how to find the reciprocals just by flipping the fraction. Don't be stumped by the fact that there's no fraction here, because if we don't have a fraction, we can easily make a fraction by just putting a 1 under whatever we have. Boom, now it's a fraction. If I want the slope of my line, keep in mind, we have to take the opposite. So I see the slope of this line was +1. That must mean the slope of my line is -1. I also know that I have to take the reciprocal. I see that my slope as a fraction is 1/1. Luckily, the reciprocal of 1/1 is still just 1/1, because you can imagine if I flipped 1/1 upside down, switching the top and the bottom, it would still say 1/1. And so I know that my slope of my line, m, is going to equal the opposite sign, which makes it negative, and then the reciprocal 1/1, but 1/1 is still just 1, so I know that my slope is just -1. Nice. So I have half of the things that I need. We said we're trying to write the equation of this line. We knew that regardless, I would need a slope. And so now we have a slope. But what else do we need? We either need an intercept to use slope-intercept form, or we need a point to use point-slope form. I definitely don't have an intercept here, but I do happen to have this point right here, -4, 1. And so we can use this point to gather my x1 and y1 information. If I were to color code, we would say that x1, y1 is equal to -4, 1, which tells us immediately, like, x1 must be whatever's in the x place, must equal -4, and y1 must be equal to 1, because that's what's in the y1 place. And so we have everything we need. We have our slope, we have our point. That's all we need for point-slope form. Now we're going to go back over here and just plug it all in. So if I want the equation of my line in point-slope form, I have to write whatever y1 equals here, whatever my slope equals here, and whatever x1 equals there. And let's go about doing that. So I'm going to start by writing the variable y, that we don't change. So y, and then I have my minus sign right after. Now we're over here at y1. We said y1 was equal to 1, and so I'm going to write the 1 right there. After our y1, I have my equal sign. I'll write my equal sign. And then I have my slope. Remember, we said the slope is -1. So I'll write that -1. After that, I see my parenthesis group. Inside of that parenthesis group, I see the variable x, subtracting whatever x1 was. And keep in mind, x1 was -4. And so I'm subtracting -4. I know you're thinking like, oh, double negatives, that's just +4. Yes, but I don't think we should skip too many steps. So I'm going to write that in the next step. But here we have it. This is the equation of our line. If you're like me and bothered by that double negative, yes, go the extra step of removing the double negative and rewriting it as a positive. For those of you who are wondering, where did the red 1 go? Well, the red 1 wasn't really doing anything. 1 doesn't do anything at all if I'm multiplying, and so I just wrote it as a negative here. But so there's the equation of our line in point-slope form.